Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this lecture, I want to discuss in detail about applications of first order and first degree differential equation, where the first order and first degree differential equation can be used. So I am going to discuss about this topic in detail. Basically, the first order and first degree differential equation can be used in electrical circuits and in mechanical engineering and other branches also. But basically, today I am going to discuss how we can use first order and first degree differential equation in electrical circuits, CR circuits, LR circuits, LCR circuits. The formation of differential equation for an electrical circuits depend upon the following law. This is law. Following law. Formation of differential equation in an electrical circuits, we use some law. Then we can apply the differential equation of first order and first degree. So first of all, I want to define some terminology of electrical circuits. Which terms are used in electrical circuit? So number one, definition of current. What is current? Every student know about the current. We cannot live without current. So what is current? So the definition of current, rate in change in charge. Rate in change in charge in time t is known as a current. Rate in change in charge means the change in charge with respect to time. That is known as a current. Rate in change in charge. Rate in charge and upon change in time. So ratio between change in charge and change in time. So that is known as a dq over dt. dq is the dq is the change in charge and dt is the change in time. So the ratio of change in charge and change in time is known as a current. So I equal to dq over dt. I is the current and q is charge. Change in charge with respect to time t. So this is the basically terminology of any circuits that is known as a current. Second point is voltage. Voltage drop across any resistance. Then resistance equal to R multiply YI. R, if voltage drop from cross any resistance, then we can write total resistance is Ri. Third point is voltage drop across inductance from any circuits, then we can write L di over dt. L multiply rate in change in current. L multiply by rate in change in current. Fourth point, voltage drop across any capacitance. Voltage drop any capacitance then we can take Q upon C. So fifth point is I denote as a current. Some I want to tell you about the some units of some terminology. So here first I is current. I is known as a current, denoted by current. Where I is denoted as a current and unit is ampere. I always be measured with the unit ampere. And Q is denoted as a charge and unit of charge is coulomb. C, coulomb means C. Represented R, this is R, resistance. Resistance represented as a R represented as a resistance. R represented as a resistance. And the unit of the resistance is ohm. R measured by ohm. Ohm is the unit of resistance. Now L represent as a inductance. And unit of inductance is Henry. At last, C represented a capacitance. And unit of capacitance, C is farad. Last, E is an electromotive force. That is constant. At last, E is an electromotive force. That is constant. R voltage unit. Unit of voltage is volt. Unit of electromotive force is volt. That is represented by volt. But E is constant. 11 is V is variable voltage. And unit of also V is volt. So in any circuits, there is Kirchhoff's law applied. Kirchhoff's law. What is Kirchhoff's law? Basically, Kirchhoff's law have two given laws. Kirchhoff's is the name of physician, very famous scientist, Kirchhoff's law, who have given two laws. One law, first law is voltage law. Second law is current law. So what is voltage law? It tells about the voltage law. So the algebraic sum of the voltage drop around any closed circuit is equal to the resultant electromotive force in the circuit. Law is the algebraic sum of the voltage drop around any closed circuit is equal to the resultant electromotive force in the circuit. Second one is current law. Current law is at a junction or node, current is coming is equal to current is going in any circuits. At a junction or node, current coming is equal to the current going. So basically, in electrical circuits, there are two circuits main. Number one, IARE series circuit. IARE series circuit. IARE series circuit means there are two components. L means inductance and R is resistance, which are added in a series in a circuits. Series system. This will be adding in a series system. So L is inductance and R is resistance will be taking in any circuits as a series. So let be the current flowing in the circuit containing resistance R. Any current flowing in a circuit, any current I, current is I is flow in the circuit, and circuit containing the elements resistance and inductance, resistance R and inductance L in series with voltage source E at any time t. So this is known as a first Kirchhoff's. So this is the LR series circuits. Any current flow from the LR circuits means this circuit containing resistance and inductance, resistance R and inductance L. Then the sum of voltage drop, current drop from L and R, this is equal to total electromotive force. So here by voltage law in LR circuit we have, what is LR? LR circuit. So this is LR circuit is this type here, this one, and this is R, and here this is L, and this is E, electromotive force, and current is flow like this. So this is the resistance and this is L inductance. So current is flow from this circuit. Then current drop around the circuits which containing resistance and inductance in a series. Then we get here resistance, in resistance I current flow from resistance R. Then by the voltage law we write here Ri, R multiply by I. If I current flow from the resistance R, then I current multiply to R plus same I current flow from inductance L, then we write here plus L di over dt. L rate in change in current, L into di over dt equal to E. E is electromotive force here. So now we write this first di over dt, here L di over dt, and dividing by L to each term we get di over dt plus R by Li equal to E by L. This is equation 1. If our circuits we have taken two components, resistance and inductance, and any current flow from these two components R and L, then the sum of voltage, sum of current is equal to the total electromotive force. So R, I and L di over dt equal to E. So here dividing by L in each term, then we get di over dt plus R by L into I equal to E by L. This is equation 1. Now we see that equation 1 is a linear differential equation of first order and first degree. This equation is known as a first order and first degree differential equation. And with the help of first order and first degree linear differential equation, we can find solution of equation 1. But we know that general linear differential equation of first order and first degree is general linear differential equation, which is the same as pattern as equation 1. So this is dy over dx plus py is equal to q. Here p and q are function of x. But in our equation this 1 I, here R by L and E by L. This is function of t. So comparing in equation 1 and equation 2, then we get this equation 2 and this equation 1. Both are same pattern. This is general linear differential equation of first order and first degree. This is given linear differential equation of first order and first degree. This is y and x, and this is I and t. Here is variable I. I is dependent variable and t is independent variable. So comparing in 1 and 2, we get similarly current here di over dt plus r by l t r by l I equal to E by L. Now dy over dx plus p y is equal to q. Compare this. In this equation is I. In our question is y. In this equation I. In our question is y. In our general equation is x. Here is t. So this is same equation. After comparing, we get p. P equal to r by l. This is the coefficient of, here is y and here is I. Coefficient of I is r by l, that is p. And in right hand side, E by l, this is q. Now solution of equation 2. 2 is general equation. So first of all, we give general formula. We will write here general formula, general solution of general linear differential equation. So here we apply formula. Formula is y into if. If is integrating factor. Integrating factor, this is if. So y into if is equal to integration q into if and dx plus c, where c is an integral constant. C is an integral constant. So now this formula we are using in equation 1. This is the solution of given equation 2. Equation 2 is general linear differential equation. And solution 3 is the solution of general linear differential equation. So now with the help of this solution, we find the solution of given equation 1. So first we will find integrating factor of 1. Then we apply formula for integrating factor, IF. IF is equal to, this is the formula which we are using here, IF equal to e to the power integral p dx. This is equation 4. Putting the value of p here, then we get IF equal to e to the power integral. What is p? P is r by l. So r by l dt. R by l is constant here. So taking out. So now formula. Apply formula here in last formula. Changing some result in last formula. Here is y. This is given in equation 2. But in equation 1, y is I. Integrating factor. This is integration q in general equation. But in our equation 1, q is e by l. So after putting value of p and q here, then we get solution of 1. So I into if is equal to q into if dt plus c. Now I into if. If is this, equation 5. Equation 5 is if. E to the power integration r by l dt equal to integration e by l. E by l is q. Q is e by l. Okay. And p is r by l. So now e by l, this is q. E की power integration r by l dt, whole dt plus c. This is I, e to the power integration r by l dt equal to e by r, integration this, integration e to the power ax and dx. So answer is e to the power ax upon A. This is the formula of integration e to the power ax. What here is e to the power integration ry dt. So integration of this e by l e की power integration ry l dt. So what is integration of this? This is same as this. No change in e to the power integration and dt plus c. So this is answer. This is the value of I. Now divide by this. Divide by this here. Then we get this result. Okay. This is the required formula for current. We apply this equation in our problem. So this is the proof of current. Formula for current. Okay. If in this question there is solution is I equal to E upon, in last solution I equal to E upon R. E upon R plus C e to the power minus R T by L. R T by L. This is the solution. Now apply initially condition to find the value of C. Apply initially condition to find C. So what is initially condition? At t equal to 0, I is 0. T is initial time. If time is 0, then there is no current flow. So I and T both are putting here 0 equal to E by R and plus C. Here putting T equal to 0. So this is 1. 0 equal to E by R plus C into 1. So C equal to minus E by R. This is the value of arbitrary constant. And this we will be putting in our question. This value putting in our question here. Then formula is I equal to E by R minus E by R e to the power minus RT upon L. This is answer. This is final solution. Now next second. We have discussed just now LR circuit. Now second circuit is CR circuit. What is CR circuit? In a circuit, they are taking two component, resistance and capacitance. So in this circuit also apply first order and first degree differential equation. So here let I be the current flow in the circuit which containing resistance R and capacitance C. Any current I flow from circuit containing resistance R and capacitance C in series with voltage source E at time t. So what happened? We have already discussed. If current flow from any resistance, then we get Ri. If current flow from any capacitance, then we get Q by C. So the total sum of these results equal to total electromagnetic force, EMF. So by voltage law, we know that Ri is the total current flow from resistance and Q by C is the total current flow from capacitance, that is Q by C. This equal to E. This equation 1. Putting I equal to, we know that the definition of I. At first point, we have defined what is current. Current is rate in change in charge. So I equal to dq over dt. Putting value of I here, then we get R in equation 1, putting I equal to dq over dt. So R dq over dt plus qy. In equation 1, we have Ri plus q by c equal to E. Putting I equal to dq upon dt. Then we get R dq upon dt plus q by c equal to E. Dividing by R in each term. Then we get dq upon dt plus q by rc equal to E by R. This is equation 2. This is linear differential equation of first order and first degree. But we know that first order and first degree differential equation is this: dy dx plus py is equal to q. This is the general linear differential equation of first order and first degree. Comparing equation 1 with equation 3, then we get 3 is general linear differential equation. Comparing equation 1 with equation 3. This is the 3 equation. Then we get value of P. P is the coefficient of Q here. So that is 1 upon RC. And Q is E by R. So now we apply formula y into IF equal to Q into IF dx plus A. This is equation 4. First we will find integrating factor of equation 1. This is general formula of integrating factor. Integrating factor equal to e to the power integral p dx. This is equation 5. Putting value of p in IF. Then we get IF equal to e to the power integration. P is 1 upon RC. P is 1 upon RC dt. So now solution of 2 is putting here. Q into IF equal to integration Q into IF dt plus C. Here is a constant. A is integration constant. We cannot take here C because C is in our question. So now this is the integrating factor. I e to the power integration 1 upon RC dt and equal to the power R. This is Q. E to the power integration 1 upon RC dt and dt plus A. So now Q into e to the power 1 upon RC integration 1 upon RC dt equal to E upon R integration of this function e to the power AX e to the power integration AX dx. Okay. So e to the power is any function. So first time that is same. E to the power integration AX dx. Now again integration of this term. So integration cancel by this. We get here 1 upon RC. So this is equation 1. Now next Q equal to U upon RC and RC plus A e to the power minus T upon RC. This is equation 8. So EC RR is cancelled. Q equal to EC plus A e to the power minus T upon RC. Apply initial condition, then we find value of A. What is initial condition? If T is 0, then Q is 0. T is 0 here. Q is 0 equal to EC and plus A and Q is T is 0 e to the power minus 1 upon RC into 0. So this is 1. So 0 equal to EC and plus A into 1. So A equal to minus EC. So now putting this value A in equation 8, then Q equal to EC and plus minus EC and e to the power minus T upon RC. So EC is common 1 minus e to the power minus t upon rc. This is q. This is the formula for finding value of q. Some problems based on electrical circuits. We want to solve here some problem that is very easy and interesting, and we have used the last formula we have already proved in our question. So problem 1 based on electrical circuits. There are only two circuits. One is LR circuit. We have discussed this LR circuit and we have already gave the formula for LR circuit. So if LR circuit, LR means inductance and resistance. These two components given in our problem. Second is CR circuit. In CR circuits, there are given two components, capacitance and resistance. So only two type of problem is there. Both problem solved with the help of linear differential equation of first order and first degree. So here a resistance of 100 ohm. In our problem, resistance of 100 ohm. This is ohm. And inductance 0.5 Henry. This is L. 0.5 Henry. Okay. Connected in a series with a battery of 20 volt. E equal to 20 volt. Okay. Find the current in a circuit. Find current I in a circuit. In a circuit, function of time. Initial condition are not given in our problem. So be taking formula 1. I formula. Formula 1 is this. I equal to E upon R. This result. I equal to E upon R minus E upon R e to the power minus R upon L T. R upon L and into T. This formula we have proved here. Okay. Now I is equal to E upon R is common and 1 minus e to the power minus R by L T. So T is not given here. T is variable. So we get a current here in variable. Variable means this is the value in time. If time is given, then current is constant. So what is value of E? Here E is 20 volt. E is 20 volt. And what is R? R is 100 ohm. What is L? L is 0.5 Henry. These are value putting in equation 1 this. This is the formula for current in LR circuit. If LR circuit is given, then we apply this formula. We have proved this formula just now. So I equal to E is 0.5 upon R is 100 and 1 minus e to the power minus R. R is 100 upon L. L is 0.5. What is E? E is 20. So here is E 20. 1 minus e to the power minus R upon L. 100 upon 0.5 and T. So this 25 is 1 by 5 e to the power E L upon R upon L. So e to the power minus point here is 1000 upon 5t. So I equal to 1 upon 5 e to the power minus 5 2 are 10. So 200t. This is the value of I. Okay. This problem solved. Now next problem 2 based on electrical circuit. We want to solve a problem which is based on electrical circuit, and in this circuit we have taken resistance and inductance, capacitance. Resistance is common in both circuit. Resistance is common. In first circuit is LR, inductance resistance, and second circuit is capacitance and resistance. So here a 20 ohms resistance is connected in series. 20 ohms resistance is connected in series with a capacitance capacitor of 0.01 farad. Capacitance farad. Unit of capacitance is farad. 0.01 farad capacitance. And EMF volt given by this e to the power minus 40 e to the power minus 3t and plus 20 e to the power minus 60. This is value of E. Here is some missing, but this value is given. Find Q if T equal to 0 and Q 0. This is initial condition. Initial conditions are given in our problem. Then we can find the value of the constant. So now we are taking formula. This is the formula for resistance and capacitance. Q equal to EC. Q equal to EC here solution. Here given us that in problem given us that resistance R is 20 ohms. Okay, and C capacitance 0.01 farad, and E is electric motive force 40 e to the power minus 2t and plus 3t and plus 20 e to the power minus 60. Okay, these 3 points are given in our question. So we apply formula here. We know the formula Q equal to EC. Q equal to EC and bracket 1 minus e to the power minus, this is e to the power minus t upon RC. T upon RC. This is formula we have proved in CR circuit. So now putting the value of Q is equal to E. What is E here? Value of E. This is value of E here. So here putting value of E. E is 40 e to the power minus. Now this is again solved. E is not constant, E is variable. So here we want to solve here again formula. So dq over dt plus qyc is equal to E. Here we starting the question in, we solve the question in starting, not using direct formula. So here are dq over dt and plus r dq over dt plus q by c. Q by c equal to E. This is equation 1. Again solve this question here. Dividing by r dq over dt plus qy rc equal to e by r. This is equation 2. Now comparing with dy dx plus py is equal to r. This is equation 3. So p is 1 by rc and q is e by r. So integrating factor e to the power integration p dx p dt. This is if. So now if is e to the power integration p is 1 upon rc and into dt. So this is e to the power t upon rc. Now writing solution formula, we know solution formula q into if is equal to integration q into if and dt plus a constant. So q into if e to the power, what is if? E to the power, this is if, t upon rc. T upon rc equal to integration q. What is q here? Q is e by r. E by r into e to the power integration integrating factor. This is t upon rc. T upon rc and dt plus a. Now q into, this is into here, q into e to the power t upon rc and this is equal to e by r is common. Now integrating this e to the power t upon rc and integrating this. So here rc, correct. R is cancelled, plus adding constant a. So q into e to the power t upon rc and is equal to ec e to the power t upon rc and plus a constant. Divide by this function, q is equal to ec and plus a upon e to the power t by rc. So now q is equal to what is q? ec and plus a e to the power minus t upon rc. This is the solution. Now t is 0, then q is 0. T is 0, then q is 0. Then we find value of a. So q is 0, ec plus a e to the power 0. This is 1. E to the power 0 is 1. So 0 ec plus a. So a equal to minus ec. After putting this value here, so q is equal to ec minus ec e to the power minus t upon rc. So ec is common in 1 minus e to the power minus t upon rc. This is the formula we have already proved in our question. Now putting all values here, then we find solution. So what is value of E? E is this. Now Q is equal to E. E is 40 e to the power minus 3t plus 20 e to the power minus 60. This is E. What is C? C is 0.01 farad. So multiply here 0.01 farad. This is EC. EC. This is total electric motive force and C. And here 1 minus. What is 1 minus is? E to the power here. E to the power minus T upon RC. R and C. So E to the power minus T. T is variable here. R is 20. And C is 0.01. Here is 1 minus E to the power minus T upon RC, R20 into 0.01. So here multiply 21 ja 20. This equal to 40 e to the power minus 3t plus 20 e to the power minus 6t and in bracket 0.01. And here 1 minus e to the power minus t. What is this result? 20. Decimal apply, this is 20. So 0.2. Apply after 2 number, this is 0.2 here. 20 multiply 0.01. 21 ja 20 and apply decimal after 2 number, so 0.2. Point is remaining here, this we get 20. This is T. Now, here is 1, 10 upon 2. So 2 5 ja 10. This Q is equal to 40 e to the power minus 3t e to the power minus 6t 0.01 and here 1 minus e to the power 5t minus 5t. So this is the Q. Okay. Now what happened in our problem? Problem is if Q is 0 then Q is 0. T is 0 then Q is 0. So we can find this result. This is the answer. Answer always in T here. Okay, this is answer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.